Today we're going to look at completing the square in a different perspective. Today we're going to look at completing the square in order to find the vertex, in order to solve other information too about the problem. So, first question states, write the quadratic function in vertex form, then identify the vertex. So, here's my equation. Y equals x squared minus 8x plus 18. So step one, I always move the y to the right-hand side just because I'm used to my equation being on left and then what it equals on the right. Then what we need to do, if you remember back, is we need to move the 18 out because there aren't any factors of 18 that give me -8 that I can think of right offhand. So that introduces the idea of adding a blank to both sides. Then we complete the square. -8 divided by 2 is -4, and -4 times -4 is a positive 16. So the number we're going to use is positive 16. So we're going to put a 16 on the left, and we're going to put a 16 on the right. Now I go ahead and I factor the left. Factors of 16 that give me -8 are -4 and -4. Remembering to carry my 16 out on the right. Remember, you can go ahead and combine these if you want. So on the left, I get x minus 4 quantity squared equals y minus 2. Now all I have to do, if you remember vertex form, it's in the form y equals, is to move over that -2. So I add 2 to both sides. And since it's x minus 4 quantity squared plus 2, we literally write it like that, not combining the -4 and the 2. Now, I always like my final answer to be in the form y equals. So I use the symmetric property to move it back over. And then now I can identify several things about my graph. My leading coefficient's positive, so it opens up. The opposite of -4 is positive 4, so it's shifted right 4. And it's up 2, so my vertex is 4, 2. And that's it. We identified the vertex. Let's try it again. So the second one, write the quadratic function in vertex form, then identify the vertex. The equation is y equals x squared plus 6x plus 4. We know right now, before we even start, the lead coefficient is positive, so it opens up, but there are no factors of 4 that give me 3 that are nice and pretty. So I rewrite my equation as x squared plus 6x plus 4 equals y. Moving the positive 4 to the other side, thus making it a negative. I am now going to complete the square. Half of 6 is 3. 3 squared is 9. So I'm going to enter in a 9 on both sides. So I'm going to infinitely clone this thing. So 9 and 9. Okay, I factor the left. Factors of 9 that give me 6 are 3 and 3. Not forgetting to add my 9 to the right. I can combine like terms now. I get x plus 3 squared equals y plus 5 because -4 plus 9 equals a positive 5. I want it in the form y equals, so I subtract my 5 over. I get x plus 3 quantity squared minus 5 equals y. And then I just rewrite it in the form I like, which is y equals. I imagine there's a 1 in front, so I could tell you this opens up. Opposite of the inside, so it'd be left 3. Vertical shift of down 5. So my vertex is -3, -5. Let's try one where there is a number in front of the x squared. So f of x equals 4x squared minus 8x plus 4. So step 1, rewrite in the form y equals. Step 2, and you might have combined steps. I write the 4x squared minus 8x plus 4 equals 1 on the left, or equals y on the left. Divide everything by the coefficient, and it doesn't matter what the number is. If it's positive, if it's negative. If it's just a -1, you still divide by it. Divide by 4. That becomes x squared minus 2x plus 1 equals y divided by 4. And you could write it as a fraction as y over 4. It's just my typing capabilities are very limited here, so I don't always am able to do so. Okay, move my 1 out to the other side. It was a positive, so now it's a negative, and I add my blank to both sides. I complete my square. Negative 2 divided by 2 is negative 1. Negative 1 times negative 1 is a positive 1, so I'm going to add a 1 to both sides. So 1 on the left and 1 on the right. Okay, so now I factor. Factors of 1 that give me negative 2 are negative 1 and negative 1. That becomes negative 1 squared equals y divided by 4, or y over 4. I square root, here if we were to solve, we would square root both sides, but that's not what we're doing. We're trying to get y by itself. So I'm going to multiply both sides by 4. If I take y divided by 4 times 4, those will cancel out, leaving me y. Now on the left-hand side, since it's a binomial square, we cannot distribute the 4 into the problem. So it just becomes 4 times the quantity x minus 1 squared. Flip it over like we're used to. This one has a stretch of a positive 4, so that means it's going to be up 4. It's going to be nice and skinny. Opposite of negative 1 is a positive 1, and nothing at the end means my vertex is at positive 1, 0. Okay, let's try one more that creates a different scenario for us. So I have f of x equals negative 3x squared plus 24x plus 6. Change it to y equals. I flip it using my symmetric property. This time, since there's a negative in front and a 3, we divide by negative 3. Even if it was just a negative, we would divide by it. So negative 3. I get x squared minus 8x minus 2 equals x divided by y divided by negative 3. Remember, that's the same thing as saying y divided by negative 3. You could put the negative in front or in the denominator. I'm just going to leave it in the denominator because later on we're going to deal with it. Okay, so now we come down here. We move our 2 over to the other side and we complete the square. Negative 8 divided by 2 is negative 4. Negative 4 squared is a positive 16. Whatever I do to the left, I do to the right. So I add 16 to both sides. So now I factor. Half of 16 is 4, so that's x minus 4, x minus 4. Not forgetting to carry down my 16. Combine my like terms. Move my constant over. Notice I did not get rid of the negative 3 first. We have to get rid of any adding or subtracting. It's the order of operations. So we get x minus 4 quantity squared minus 18 equals y divided by negative 3. I'm going to take both sides times the negative 3. Just like before, by multiplying by negative 3. The negative 3's will cancel out, leaving me y. And on the left, we actually have to distribute it in. So negative 3 times x minus 4 squared is negative 3x minus 4 squared. Noticing I have to take that negative 3 times that negative 18 also, which is a positive 54. Flip it around. Well, this thing opens down as a stretch of 3. It's the opposite of the inside, so 454 is my vertex. Now, where could I apply this other than just finding the vertex? Well, we're going to do one application problem together. The problem states the following. The height and feet of a baseball hit t seconds after it is hit can be modeled by the equation or function y equals negative 16xt squared plus 96t plus 3. Find the maximum height of the baseball. How long does the ball take to hit the ground? Well, we know maximum height, and we know this is a parabola, so this thing opens down. So we're wanting to find the vertex. So that's what we're going to do. We're going to complete the square. So I set up my math problem just like we did all the others, making it equal to y. I divide by the leading coefficient, which is a negative 16. Now this one gets kind of messy. The 16s cancel out. 96 divided by negative 16 is negative 6. 3 divided by negative 16 is fortunately is negative 3/16. And then we get y divided by negative 16. I add my 3/16 over to both sides, thus getting it on the right-hand side and creating my spot for completing the square. Half of negative 6 is negative 3. Negative 3 times negative 3 is positive 9. So I'm going to add 9 to both sides. Half of negative 6 is negative 3, so it's t minus 3, t minus 3. Y divided by negative 16 plus 3 over 16 plus 9. Condense. T minus 3 squared equals y minus 16 plus 9 and 3/16. Then I make it improper, and we've talked about this last class period. Take 16 times 9 and add 3 to it. We get 147 over 16. Move my whole number. In this case, my whole number is actually a rational number, 147 over 16, to the other side. Divide both sides by negative 16. Okay, what happens there is because we distribute it in. We get negative 16. A negative times a negative is a positive. The 16s will cancel, gives me 147. So we get y equals negative 16 t minus 3 squared plus 147. Okay. This thing opens down, which it should. If you're hitting a baseball, it's going to fly up and fly back down. Okay, t minus 3, opposite, equal to 0, so we get 3, comma 147. Okay, if I graph this bad boy, we would have part of a graph, the part you can see here, kind of hiding some stuff. Okay, the ball hits up and comes back down. So that is the maximum height. So after 3 seconds, the ball is at a maximum height of 147 feet. Okay, but the question asks, how long does it take for it to hit the ground? Well, if you think of ground as your height would be 0. So what we have to then do is set it equal to 0. So I have this math problem. I'm setting it equal to 0 because I want the result would be where it would hit the ground. Okay, so now since I've already completed the square, I can just use inverses to solve. So I'm going to start by subtracting 147 from both sides. I get negative 16 times the quantity t minus 3 squared equals negative 147. I divide both sides by negative 16. I get t minus 3 squared equals 9.1875. Now, you can leave it as a fraction, but I'm not worried about it here. And this is the one time I'm not worried about it, because they want to know the whole distance, and you're not going to say, well, it's the square root of 147 or 16. You're going to give them an answer to this. So the exact answer so far is 9.1875. Square root both sides. You get t minus 3 equals approximately plus or minus 3.03, and I think it goes on to say 1 something. Add 3 over. You get 3 plus 3.03, which is 6.03, or 3 minus 3.03, which is negative 0.03. So if I look at the rest of my graph, okay, that's pretty much what it shows right there, because it's basically 0 here and 0 there. Okay, so now if we look at it, let's think about it. They want to know when it hits the ground, so they don't want the value on the left. They only want the value on the right. So that is why I nixed the negative 0.03, or about negative 0, or 0, because 6.03 would be the only logical answer here. So today's objectives, repeating. We had to complete the square in a function in order to find its vertex. We also use that idea to apply it to mathematics in the real world to find the maximum height of the ball and how long it would take to get to the maximum height. Then we also use that idea to find out how long it would take for it to hit the ground. So I hope this is helpful in finishing 3.3. Until next time, Mrs. Dorn.